Good afternoon, ma'am. Welcome back to the afternoon session, ma'am. Ma'am, good afternoon, ma'am. It is audible, ma'am. Ma'am, good afternoon. It is audible, ma'am.
Yes, good afternoon. Am I audible now?
Yes, ma'am. Audible, ma'am. Good
Okay.
afternoon, ma'am. Welcome back to the session, ma'am.
Thank you. And shall we proceed with the session or should I wait?
I can go ahead, ma'am.
Okay. So I'll start sharing my screen. Okay, I think now my screen is visible. So we'll start from our ninth question, which is using the for loop for printing the pattern. So there are different kind of patterns. Whenever the question is related to patterns, first we need to think that it is going to be in a kind of nested looping. So for this kind of, it is a very simple pattern that we see here. It is like a right angled triangle. So for the right angled triangle, first we need to identify how many number of rows I'm going to print, and in each row for how many number of times I'm going to print the star. So this is a simple for loop that I have defined inside a method which is star pattern. So the argument that is going to be passed is number of rows. So we all know for loop works with the concept of a range starting value. This is the ending value. Since I want the rows value also to be included, we all know stop value gets reduced before. So to have the last value included, I'm just writing it as rows plus 1. So the possible values would be 1, 2, 3, 4, and 5. In case if rows is 5, I value is going to be in the range of 1, 2, 3, 4, and 5. And then you can see the indentation here. Now for like in each row I need to print the stars. The stars correspond to the row count. So in first row it is going to print one time, second row it is going to print it for 2 times. So for j in range of I, so every time the number of depending on the I value, I'm going to print the star for that many number of times. So the inner for loop is for j in range of I. That's it. So this represents what it means is if I don't give this part, which is end is equal to, print would automatically print the value whatever I have given inside the double quotes in new line every time. But you see, for all these stars must be printed in a same line. So to make that possible, you need to give end equal to. So what I want to end my line with. After printing a single star, I don't want to end it. That's why I'm giving it as end is equal to empty double quotes. If I give empty double quotes, it keeps printing all the stars in the same line. And to move to the next line, once I finish every line, I need to move to the next line. For that, I'm just giving print. So is this explanation okay? Shall I move to the next question? Yes, shall I proceed with the next program? Is everything fine?
Yes, ma'am.
Okay, thank you. Thanks for the reply, ma'am. The same kind of pattern, but in a reverse way. So what you're going to do, I'm just going to reverse this range. So now I'll start with rows. So why I'm not using here rows plus 1 is start value is inclusive. So it includes a row value And since here it is 0, it will stop before 0, which is 1. And third argument is your step. So rows is a starting value, 0 is your stopping value, minus 1 is your step value. Minus 1 represents I'm going it in the descending order. So in the descending order, the same thing for the line I times, I'm going to print the star every time. So that's why I have an inner loop with the same end equal to empty double quotes, which means it is going to print the stars in the same single line. And this will make me to print a new line. And here it is a little bit. So first, these two patterns are a little bit easier. So then we have a pyramid type of pattern. Here you need to focus that. When I see the first line, you can see the star starts printing only after a certain amount of space, followed by certain amount of space, followed by a star. In the second line, I have certain amount of space, followed by my stars. So what is that logic? I need to think of that for that. So obviously my first for loop is going to be for how many number of lines. Number of lines is in this case the rows is 5. I'm going to print have the loop running it for 5 times. And every time what I'm going to do, I'm going to print the empty space here. So you know that any string multiplied by any integer value in Python, it prints the particular string for that many number of times. So here I'm going to print a space. So within the double quotes, I think you can see a space here. The space gets printed for rows minus 1 times. This is a space followed by I need to print a star. So how many number of stars should I print in each line? For that, we have a logic here. For the first line, it prints 1 time. For the second line, it prints 3 times. For the third line, it prints 5 times, which is nothing but 2 times the line number minus 1. So 2 into 2 minus 1 is 3. 2 into 3 is 6 minus 1 is 5. 2 into 4 is 8 minus 1 7. So I have 7 stars. So this is 2 into I minus 1. That many number of times I need to print the star. So star is a string here multiplied by 2 minus I, 2 into I minus 1. So that many number of times I'm going to print it. We'll move to the next question, which is finding a logic for finding whether the number is a prime number or not. So I'm just going to define a method, which is I'm going to check whether a number is prime or not. That is the logic returned here. But the question asked is they are asking you to print the numbers from 1 to 20. So to print it, to find all the numbers that are prime numbers in 1 to 20, I need to have a for loop. So the for loop starts from 2 till 19. So since 20 is stopping, your loop stops beforehand, which is 19. Why I'm not including 1 is 1 and it can either be prime nor be composite. So will not be including 1, will start from 2. So this for loop will check all the numbers. It checks whether it is prime or not using the logic here. If it is a prime, it returns true, then I'm going to print the number. Else I'm not going to do anything. I'll proceed with the next number. So how I'm going to check the number here? First of all, I'm going to check whether the number is less than 2. Obviously, if the number is less than 2, it is not a prime number, so I'm returning false. In case if the number is greater than 2, then I would move to, I'm going to check whether the number is divisible by all the other numbers or not. So for that, I need to start from 2 and I can go up to square root of. So this part int of num star star. So star star represents power symbol, power of 0.5 half. So any number to the power of half is nothing but square root. So square root of number plus 1. So until that, I'm going to check any number is dividing my I or not. So to check the divisibility, you know the formula, which is modulus. So modulus I, it will be equal to 0 if number is exactly divisible by I. So if it is divisible, then I can carefully say that number is not at all a prime number. I am going to return false. In case the num is not at all divisible by any of the number in this for loop, then I can guaranteely return that it is a prime. I'm going to return a true value. So here is if condition. So if returns a true value, I'm going to print the number and I'm going to end it with a space, which means all the numbers will be printed in the same line separated by a space. So you can see the output here. So in our previous example where we printed the pattern, we didn't have any space at all. We had all the continuous stars. But here I want the numbers to be printed with a space. You can use end equal to. In case if I didn't use this part, So what you will be getting, if I don't give end equal to, then my all my numbers would be printed in a new line. Only that's the difference, nothing else. So here we are making the function call. So from here the control goes, once the method is called, your control goes here, and here you have a for loop. In the for loop, for every number, you are going to call the method is prime. Next, they will be going into is a recursion concept. So, subsequently, three programs that we are going to see is using the recursion concept. So, in recursion concept, you need to remember that you need to have two components. The one component is your base case, and second component is your recursive case. These two are the mandatory components that you need to have. So, what is a base case? Base case is nothing but your stopping condition. When I want to stop the recursion, that is your stopping case. And when my base case is not happening, what I need to do, I need to keep calling the function. So that is the base case here. So for finding the factorial of a number, we are going to define the method, define def factorial of n. So now I'm going to check. So when I'm going to stop calculating the factorial, I know definitely 0 factorial or 1 factorial, the answer is going to be 1. So that is my stopping case. So here I'm going to check if n is 0 or n is 1, return 1. That is a guaranteed answer. Else what I'm going to do, I'm going to calculate n into n minus 1. So I'm going to write it as return n into, say I have again recursively called the same function, which is your factorial. This is my recursive case. So you are supposed to have the base case and recursive case. In case you are not able to properly write the base case, you might lead into a infinite function calling, which may you will be getting an error like timeout in calculation, so on. So be careful. You need to have a proper base case whenever you are defining a recursive function. Shall I proceed to the next question, or should I wait for the people to work out or make anything? How you want the session to be proceeded? Any suggestions? Or can I keep proceeding with the next questions? Okay, then we will move to the next question, which is again a recursive function, which is adding of two numbers. So adding of two numbers, how I'm going to make it recursive is, I'm going to keep adding one to another number. I'll keep reducing one in another number. So when I'm going to stop it, so I keep on reducing one number in B, adding one to A. Keep reducing one in B, add one to A. So I keep doing it until I reach B equal to 0. If I reach the condition B equal to 0, then obviously my answer is stored in A. So I'm going to return A here. So this is my base case. First, we need to define the base case. Else what I'm going to do, I'm going to call the same function for how many number of times? For the next time when I make a call, I'm going to add one value to A and reduce one value to B. That is why I'm going to make the same function call with the arguments A plus 1 and B minus 1. So that is the concept of recursion here, to add the two positive numbers. Now, if you are familiar with this technique, then the next question would be easier, which is using the recursive function to multiply two positive integers. So if I want to keep multiplying two positive integers, we all know multiplication is nothing but repeated addition. That is what we might have studied in our elementary school. So division is repeated subtraction, multiplication is repeated addition. So already we did our recursive addition. We are going to apply the same concept here. So I need to keep adding, repeated adding until I reach my base condition, which is b is equal to 0. If my b is 0, my sum is going to be 0. So answer is 0, return 0. Else what I'm going to do? I'm going to add a with a into b minus 1. So we all know a into b is equal to a into b minus 1 plus a. That is what the recursion we have specified here. So it is almost similar to our previous adding of two numbers. It is the same recursion concept that we'll be using. So when I execute it, if I give the value of 5 and 3, so what happens is 5 gets added for 3 times. So our answer is going to be 15. So this printf statement that we see here is a formatted printing. So formatted printing is whatever that I put within the curly brackets here that you see, num1, num2 and result, the corresponding values of those variables. So we have three variables here, which is num1, num2 and result. Those values get printed instead of this. So the answer is the product of 5 and 3 is 15. So we have one more recursive function question, which is greatest common divisor. So greatest common divisor is going to be based on an Euclidean algorithm. We all know, very familiar question. We have a GCD algorithm. So GCD algorithm states that if I want to find the GCD of A and B, okay, finding the A and B, GCD of A comma B, you have a condition if B is equal to 0, then answer is A. Else GCD of A comma B is equal to GCD of, which is again a recursion, GCD of A comma B comma A mod B. This is what the Euclidean algorithm stated. So let me highlight that. Okay, so from this figure, you can identify we have all the two components that we require for our recursive function. Here, when B is 0, I'm going to return A. That is my base case. When A and B are not 0, then I'm going to make a recursive call. Recursive call of, instead of GCD of A comma B, I'm going to call it as again GCD of B comma A mod B. This is my recursive case. So if you are able to understand this, then you'll be able to understand this question. So I'll explain this with an example. In case you are given with find the GCD of 17 comma, maybe I'll go with any 9. So this is equal to GCD of, since 9 comma 17 and 9 we are not going to get satisfied with the base case, so we'll go with the recursive case. Now the problem gets reduced into GCD of 17 comma 9 is equal to GCD of 9 comma 8. Again we go with again the recursion. Now it becomes GCD of 8 comma 1. Again the process continues. Now it is GCD of 1 comma, we all know 8 mod 1 is 0. So now I have reached my base case where my B value is 0. So obviously my answer is going to be 1. So this is how your Euclidean algorithm keeps working. So for that, we have our base case, we have our recursion case. So A mod B, that would be a short form. So whenever you are writing it as a Python program, we have our operator, which is our percentage symbol. Okay, so before moving to the next thing, we'll get strong with the recursive function. Now, can you all people work out for the recursive function for multiplying two positive integers and finding the GCD of two numbers? Let me wait for 10 minutes. You can copy the code from the screen. I'll share the Word document, entire document once again. Do you need time for working out from the 9th question, or we can proceed with the 13th question that you see on the screen? You can put it in the comment box. Which are the question you want me to display? You can work out with the 13th question. Okay, now we'll move to the GCD question. You can work out with the GCD. So whatever I have put out here in red line, those are all command lines. You need not type those things. You can leave out all the command lines that preceding with a hash symbol. So define a recursive function. This is also a command line. And you need to have these 4 lines. So please work it out. In case you have finished the GCD question, I'll give you some time to think the logic for printing a inverted pyramid. So for the pyramid, I have given you the logic here. So you need to reverse the for loop content to have your inverted. So let me put everything into a single screen so that it is visible for you. Yeah. So this logic is for the pyramid that is printed here. Now I want you to think of how to invert this for loop to get the inverted pyramid. So you can take your time to think of the logic and see whether you are able to get this inverted pyramid. Okay, I think I have given enough time for that. Start with the GCD. Okay, so next question is finding whether a triangle is a right angle triangle or not. So to find whether a given triangle is a right angle triangle, we need to use the Pythagoras theorem. So Pythagorean theorem states that the square of the third side, which is the largest side, must be equal to sum of the squares of the other two sides. So that is what we have studied, which is a square plus b square is equal to c square. So for that, first thing I need is I need all the three sides. So those are the three arguments for my method, which is checking whether it's a right angle or not. So that is a function I'm defining with three arguments or three sides A, B, and C. So to understand which is a to find out which is the largest and which are the other two smaller sides, we need to sort the values. So to sort that, we have an inbuilt function called sorted. So sorted can be applied only on a list. So what I'm going to do is I'm going to make all these three sides A, B, C into a list by just simply enclosing them within a square bracket. So enclosing them within a square bracket makes them as a list. Now what happens? This list gets sorted in a ascending order, and the sorted list will be stored in the name of sites. So sites of 0 will be the smallest site, sites of 1 would be the next largest, and sites of 2 would be the bigger site. So I'm going to check whether sites 0 square, sites 1 square, which is my a square. So this is my a side, this is my b side. So a square per double star represents a power symbol. So a square plus b square, whether is that closely equal to c square. So sites of 2 is my largest side, which is c. So if they are equal, then I'm going to return true. In the math class, we already have is close function that is going to check whether these two values are close enough, or they are identical. If they are same, then this function will already return a true value, and that true value will be returned by this function. Else I'm going to return the false value. So what I'm defining it in the main, I'm going to get the three inputs. We all know how to get the input, so using input function. Since I want the values to be accepted in the form of float, I'm going to do the type conversion here using float of. So float of, input of, enter the length. So this would store the value in the form of float in A, B, and C. So there might be sometimes user might enter a non-numerical data, maybe any alphabetical data. So that cannot be get converted into float. In those scenarios, I need to throw the error. So for that, we are enclosing them within a try block. So try block would check for any of the errors. If there is an error, then that control will go back to except statement. So further, these statements will not be executed. If there is any error while reading the input from the keyboard for A, B, or C, your control will directly pass into the except value error. So the value error is when it is expecting the numerical, you're giving alphabetical, that is a value error. So it prints the error message, please enter the valid numbers. Else what I'm going to do, I'm going to call the method function that we have defined. What our function is right angle. Is underscore right underscore triangle. I'm going to pass three values. So that is what I'm doing here. Since it returns a boolean true or false, I'm just putting it in the if condition. If this method function returns a true value, I'm going to print the triangle is a right triangle. Else I'm going to print the triangle is a not a right triangle. Okay, so everything I have defined it in a method called main. Now, simply if you want, you can create this as a package and you can use this method anywhere. Or if I want to execute it directly in my console, then you may have make the call for your main method by just simply calling. So this is actually your function call. Function call to main. Okay. So when this function call happens, since it is placed inside the if, only if the condition is true. So what is the condition? If the name of my file is main, then I'm going to execute it. Which is nothing but if you put this, you can execute your file as a script in your console. Else, I don't want these things. I just want to define the method. I'm going to use my method elsewhere. Then you can just simply put the method in a package. That's sufficient. So I'll give you 2 to 3 minutes of time for you people. You can just type this question. Let me show the code in a single screen for you. Okay. Yes, I hope you can see the entire screen now. You can just type it. So lastly, you can have the please enter valid numbers. That is your error message. You can just execute and see what you're able to get it, whether you're getting any error or you're getting the output. I'll wait for 2 minutes. Okay, so I'll move with the next question if you don't have any queries. So next is finding the Fibonacci series and creating a new module. So we are going to use the recursive concept here once again, but that recursive concept is written as a separate module and I'm going to import it into my another package. So first we will see what is the recursive logic that we have defined for a Fibonacci. So we have a Fibonacci function with the argument n. First we need to have a base case. So what is the base case is, if they are asking you the first Fibonacci number or second Fibonacci number, obviously our answer is going to be 0 and 1 respectively. So first Fibonacci number is 0, second Fibonacci number is 1. That is what we start with. So that is our base case. So these two are the base cases. And this is in case if you are giving any negative number, to throw an error, we have a if condition. So it is not that your recursive function should have one base case. Minimal, it need to have one base case. More than that, it may have multiple base cases. But make sure at least one of the base cases getting executed. So after the base case, we have our recursive case. So what's the recursive case is? A and B are going to be 0 and 1. So this statement, here we have a multiple assignment is using the equal to operator. So A will have the value 0, B will have the value 1. Now what I'm going to do, I'm going to keep iterating it. And every time what I'm going to do, B value gets assigned to A plus B value gets assigned to B. So that is how we are going to have our Fibonacci series. You people all know Fibonacci series will start with a 0, 0, 1, followed by 0 plus 1 is again 1, then 1 plus 1 is 2, then 1 plus 2 is 3, 2 plus 3 is 5, then it goes on. So this is how it goes on. So that is for that logic we have written a comma b is equal to b comma a plus b. So once I am reaching the particular number, so this input is in case if I give the input 7, it will count the seventh Fibonacci series. First number, second number, third number, fourth number, fifth number, sixth number, seventh number. So 8 is my seventh Fibonacci number. So that is what it is going to return. For that, we have our for loop. And finally, the answer is stored in variable b. I'm going to return b. So I have defined this function and I'm storing it in the name of Fibonacci module. Okay, so now I'm making it as a model. What I'm going to do, I'm going to use this Fibonacci function in my another program, which is my main program. For that, you need to have a import statement. So far we have imported math packages. In case if you want, we'll be importing some other packages. So to import some modules or packages into your program, you're going to have the import statement. So from my module name, so from is a keyword, followed by from which module. So my module name is Fibonacci underscore module. I'm going to import. So my module may have multiple methods, multiple functions. In this case, I have only one function, which is Fibonacci. So I'm going to import Fibonacci. So once I import it, which means that the function gets loaded into my program. So I can call it as usual, as if it is present inside my main program. Now I'm going to have my main. As usual, I'm going to get the input. Now input is on the form of integer. That's why we have a typecasting of int, and that value gets stored in index. If you're giving a non-numerical value, since it is in a try block, you will get an error. The error would be for if you're giving a non-numerical value, you'll get the value error. In case you are not able to load this module, sometimes it may occur in case a module is not able to be located or it is not in the specified location, you might get the import error. So in that case, this exception will be thrown. Okay, so fail to import the module. Else what happens? So in our try, we get the input. The input is in the form of index. I'm going to call the Fibonacci method with the argument index. Index as my argument. I'm going to find the seventh number. I'm going to find the fifth number of the Fibonacci. So in that case, index would be 5 or index would be 7. And the result, whatever the value that is returned here as a B, that would be stored in the name of result. I'm just printing the result. So this concept I told you already. So if I want to run it as a standalone script, I just by calling the name of the program, which is main program.py, want to get executed, then you can have your script like this. So you can define your Fibonacci module here. I'll give you 5 minutes time. I'll show you the Fibonacci module. First type the Fibonacci module. Then you can type your main program. I will show that also. First, we'll finish a Fibonacci module.
This is your main program. You can type this content by importing your Fibonacci method from Fibonacci underscore module. Okay, I will move to the next question now. So next is also to define a new module that has all the functions. So in our previous case, we had only single model with a single function. Now we will have the multiple modules. Sorry, I'm sorry. Also multiple meta functions like all the arithmetic operations, add, subtract, multiply, and divide. I'm going to write all these functions inside a single module with the math underscore operation. So now my module name is math underscore operations. And if I want to import only the specific function into my program, I can just write it at from a math underscore operations import subtract. From math underscore operations import add. That's a case. In case I want all the functions to be included in my program, I need not write all the four functions separately as a four import statement. You can just simply write it as import math underscore operations. That would be fine. So in our example, we have import from math underscore operations. I'm going to import the add function alone. So I'm only possible to call add function. I will not be able to call the subtract or multiply or division. So here inside whatever the logic is simple a return statement with all the arithmetic operators. Only for the division thing, I have a divide. I'm going to have a divide arithmetic exception in case if my divisor is 0, which is b is 0, I'm going to show an error message. I cannot perform the division, else I'll be performing the normal division. So this is my module. I have prepared my module. Now I'm going to import it from math underscore operations. I'm importing the add function. In my main, I'm going to get the two inputs. So whenever you're trying to get the input, you're enclosed within a try block, so that if user by any chance gives an non-numerical value, you'll get into an error. So to handle that kind of error, we are having the value error. Okay, if everything goes fine and user enters a float value, I'm going to call the add function by passing the two arguments num1 and num2 into the result variable. Now result variable holds the value. I'm printing it with the formatting. The sum of num1 and num2 is result. And as usual, the as I said earlier, if I want to run it as a solo script in my console, I'm going to have with if condition, I'm making a call to my main function. Okay, so that's it. Now, I want if you want to have a module created using your math operations, define all the functions separately, put them in under a math underscore operations package, sorry, module, and then import any one function. Not only add, you may include divide or multiply something else, or instead of this, if I want all those things to be included, then just type import math underscore operations. This would do. So this statement will import all the functions in your program. Then you keep calling any of the functions that you want. So this is useful to import all functions. So for create a module named math operations, then we will proceed. Now import all the functions in math underscore operations module into your main function. Instead of just calling only the add method or add function, you may try to call all the different functions, that is subtraction, division, and multiplication, and see the results.
Okay, we'll move to the last question, which is whether it is a valid number or not. Or the number that I give is a valid mobile number or not, that we are going to check inside a function. So as usual, like how we check whether it is a prime number or not, I'm going to define a function that will return either true or false. So for that, so in Python, we have a rich package, which is a regular expression. So to use all the regular expression methods and patterns, you need to import the regular package. So for that, you need to import re. So re is a standard regular expression package that is already available. Once you import it, only then you can first define the pattern. So whenever you are using regular expression to perform something, to search the pattern, or once I search the pattern, I may do multiple tasks, like I may substitute the pattern with another pattern, or I may delete the pattern or do something, whatever I want. So further, first I need to define the pattern. To define the pattern, okay. So first I'm going to define the pattern. Let me explain what this pattern means. So in Python, your string will be enclosed within a single or double quotes, or whatever the or even a triple quotes. So here in this case, we are using a single quote. And what this R represents is, generally when you have a string, they are all of ASCII codes, but I want sometime my pattern to contain Unicode characters. So whatever the characters that I inside posted, it may have Unicode characters. So in that case, I want Python to consider this as a raw string instead of a normal ASCII string. So to denote that this must be considered as a raw, always preceded with the R. இதை விட உனக்குனால கத்தவே முடியாதாட்டிருக்கு. So preceding with R, it denotes it is a raw string that contains Unicode characters. Now what I'm going to do is, it is going to check whether my number begins with. So whatever the string that I give must begin with, for that your cap symbol, and it also must end with a digit. So it must begin with a digit, for that we have cap. It must also end with a digit, for that we have the dollar symbol. So slash d represents the digits. So my string should have the pattern that I'm going to check will have only the digits. And how many number of digits are allowed? That is the occurrence. So occurrence count is 10. So we usually know that all the mobile number have 10 digits. So the D represents a digit. How many digits should my pattern have? 10 digits. That is represented inside the curly bracket. So now this is a pattern. So once I define the pattern, I'm going to use match function that is already defined in regular expression package RE. So RE dot match of whatever the input that I have given. See, our regular expression will work only on the strings. Even though you are getting the mobile number, you need to get it in the form of a string. That's why I'm not performing the any typecasting here. So I get the number, that number gets passed here, and this number, in that number, I'm matching the pattern, whether I am able to find this pattern. This pattern represents beginning and ending with a 10 digit. If the match, there is a match of pattern in this number, I'm going to return true. Obviously, the number is a mobile number, valid mobile number. Else, it is going to return a false. So in my main, since I'm getting the input, my input is enclosed within a try block. If there is a value error, which means any type mismatch, the error will be shown. Or if the proper input is given, I'm going to call the method, by passing the value number. Now the function might return true or false. It returns true when there is an exact match for the pattern, which is a valid mobile number. I'll print the number is a valid mobile number. Else I'm going to print it is not a valid mobile number. So let me first give you time for you people to define the function. இந்தாங்க யாராவது சாப்பிட்டோம். ஐயோ எனக்கு வேண்டாம், வேஸ்டா போயிடும், யாராவது சாப்பிட்டோம். பாரு அவன் ஆர்வமா இருக்கான். Okay, I hope we had come to the end of the session where I have mostly explained all the concepts that are involved in these programs. And in any case, if people have any query to ask me, the session is open now for you people to ask any queries. Else, I think we can end the session here. I hope that was a great pleasure to make to share this kind of knowledge with all those people from this prestigious institute. So thanks for giving me this opportunity. Any queries, please?
Participant, if you don't have any queries, shall we wind up the session?
Okay, so someone has posted in the message that they don't have any kind of doubts. Okay, so that's good to hear. Ma'am, in that case, can we wind it up?
Yeah, okay, ma'am.
Okay, thank you, ma'am.
I would like to thank you for the excellent session, ma'am. And thank
Okay,
you
thank
all
you.
for the participant for
I
spending
also
your
once again
valuable time.
thank everyone.
Yeah, thank you all.